Hi, I'm Mr. Marlon P. Molo. Today, I'm going to share to you how to answer a problem related to rates. Let's jump in. Try to consider this problem. A boat is pulled in by means of a winch on a dock 12 feet above the deck of the boat. The winch pulls in the rope at the rate of 4 feet per second. Determine the speed of the boat when there is 13 feet of rope out. So here's the basic understanding of the given problem here. We're talking about the winch, the dock, the deck, and the boat. Our complete representation here represents everything. Here's the dock, which is our height, alright? And where is the winch? The winch is here above the dock, and the rope is attached to it. Attached to the winch. Here's the rope. Rope is our R, and here is the boat. The boat is above the sea level. And it says that the winch pulls the rope at the rate of 4 feet per second. Do you know the term rate? Its derivative. What's derivative? What's rate? The rope. So we have here the derivative of the rope with respect to the derivative of the time is 4 feet per second. The question is, would it be positive or negative? Well, the winch is something to do like a pulley. We are cracking the boat in. If the rope is way far out from the dock, which means the boat is getting far from the dock, the length of the rope is getting longer. But since the winch is pulling the boat, here's the boat, and the winch is pulling it. It's going to be towards the dock, moving towards the dock. It means we can consider it a negative. If we say that the boat is our B, the boat is moving closer to the dock. It's not like we're pulling the boat flying out to the water, something above the dock, but we are pulling the boat. No, the winch is pulling the boat closer to the dock, meaning the distance is getting smaller, closer to the dock. So we have here, we can consider it negative. And now, determine the speed of the boat. Once again, do you know the word speed? It's another derivative, right? What's speed? It's the boat. So we have here the derivative of the boat with the derivative of the time is our problem, is the question. When there is 13 feet of rope out, this is our rope. R equals 30 feet. Okay, now the question is, how are we going to relate all of these ideas into one equation? I guess, well, we see a triangle here. It's going to our representation a while ago. Obviously, we see a triangle, right? So what we have here is this one. This is our B, which is our boat, and this is our H, the height of the deck, and the whole thing out here is our rope, which is R as our hypotenuse. Now looking up to this drawing, looking up to this presentation, what we know in the previous lesson, we can use and we can relate it to the Pythagorean theorem. We have B squared plus H squared equals R squared. Awesome. Just like that. Alright, now we have already a Pythagorean theorem, and we can now use our knowledge about derivative. So let's start. The derivative of B squared, we know that this is going to be 2B times derivative of the both with respect to the time. Okay? Plus the derivative of H squared. Now, going back to this problem, you know that our H here will be the height of the deck, which is basically 12 feet above the deck, which means it is a constant number. And we know that the derivative of a constant number is 0. We can write 0 here or not at all. Equals the derivative of R squared is 2R times the derivative of the row with respect to the time. Awesome. That's it. Now, to continue the process, obviously, what we have here. So we can cancel it out, the 2B, meaning we are going to divide it both equation, both sides with the 2B. Okay? So cancel it out, and here we have that one. Now, dB dt equals R times. So what is our R? dr over dt. dr over dt, we have a negative 4 over B. Okay, we have something lacking here. dB dt equals our R. We have 13 times negative 4 all over B. Are we done? No, we are not yet done. We still miss a missing piece of the puzzle here, which is B. Meaning, going back to our Pythagorean theorem here, we are going to look, or there is something here which is constant, right? We are going to find the value of B for us to proceed to the process. Okay? Now I'm going to bring you to our previous lesson here. especially here. This one and this one. Okay? Now, what we have here is another triangle. Okay? This is our B. This is our H, which is our height is 12, right? And our R, which is basically the hypotenuse of our triangle, is 13. Looking up to that illustration, to that presentation, we can also use the Pythagorean theorem. And we say, since we're looking for B, we have here base squared equals, or the square root of base squared equals the square root of, we have root, we have 13 the root squared minus 12 squared. We are going to simplify it. Here we have the square root of b squared equals the square root of 13 squared. We have 169 minus 12 squared. We have 144. That's it. Now we have to continue. The square root of b squared equals the square root of 169 minus 144 equals 25. Are we done? Not yet. Okay. We are going to bring this one here, this side, and we are going to continue the process. We have the square root of b squared is b equals the square root of 25 is simply 5. Alright. Now, since we have already the value or variable b here, I guess we can proceed to the process now. But here, I'm going to use the other side of the board for us to continue the process here. So we are going to write this one here. This one. Okay. We have dB dt equals 13 times negative 4 all over b. So what we are going to do now, since we have already the value of our b, which is 5, we will simply substitute this value to this equation. Okay? We have dB dt equals 13 times 4 over 5, which is basically feet per second. Okay? So, if we are going to continue that one, we will multiply 13 minus 4, 13 times 4 divided by 5, and that would be our answer here. Okay, so I hope you learned something from our sharing this moment, and thank you so much for watching my video, and hopefully next time I can make more videos for you and I can help you with your little problem. No. We will look at other problems related on words. Thank you.